Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next example on the midterm test. Here we have to find this matrix, this -1, 0, 3, 1, to the power of 44. So basically what this matrix is going to be if we multiply it by itself 44 times. Okay, and with these kinds of questions, what you want to do here is you want to try to figure out what is the pattern going to be. Right? If you multiply first two matrices by themselves and then three and then four. So let's start off with finding out what's going to be if we multiply this matrix by itself just twice. Right? So we'll call this A2, meaning that we're basically going to write out this matrix twice like this, right? This to the power of 2. So what's going to happen here is, remember when we're multiplying two matrices, what we do is we take the rows from the first matrix and multiply it by the columns of the second matrix. And notice that this is a 2 by 2, right? It's like a 2 by 2 matrix multiplied by a 2 by 2. So we know these middle terms cancel out. We know that our resulting matrix is going to be a 2 by 2. Right? And so let's find out what are the entries here going to be in the resulting matrix. So if I multiply this first row by this column, -1 times -1 is +1, 3 times 0, that just gives us 1. And then this entry right here, second row, first column, 0 times -1 is 0, plus 1 times 0, that's going to be 0 right here. Okay, and then we take this row multiplied by this column, so -1 times 3 is -3, plus 3 times 1, that would give us 0. And then for this entry, second row, second column, so second row, second column, 0 times 3, plus 1 times 1 gives us 1. So notice actually that the second matrix, or rather if we take this matrix and multiply it by itself twice, we end up with the identity matrix, right? And so now what's going to be if we take this matrix and take it to the power of 3, right? So if we take this to the power of 3, well, we already know what the product is of the first two matrices multiplied. It's just going to be this identity matrix. And now we're going to be multiplying it by another one of these, right? So this was the product of the first two. So think about this matrix written out 3 times. The product of the first two is the identity matrix here. And then we still have this third matrix that is roaming around. So we got to multiply these two now. Basically, an identity matrix times the original matrix is going to be the same thing, but let's see what we get. So it's going to be the first row, first column. So 1 times -1 plus 0 times 0, that's going to be -1, like that. Okay, and then this is going to be the second row, first column. So second row, first column, 0 times -1 plus 1 times 0, that's going to be 0. Okay, and then the first row, second column, so first row here, second column, 1 times 3 plus 0 times 1 gives us 3. And then the second row times the second column, 0 times 3 plus 1 times 1 gives us 1, like that. Right? And so notice that we end up with the same matrix that we originally started with. Right? So notice that this is going to be if we multiply it 3 times. So then if we multiply it 4 times times this, we already know is going to give us the identity matrix. Right? So this matrix e to the power of 4, we're going to end up with the identity matrix again, right? So you could see the pattern. So basically what's happening is like, let me kind of maybe write it on the side here. So let's say that this matrix, let's just call it A. And before I put a subscript 2, I'm just going to put, okay, what's a squared going to be? Well, a squared we know is going to be the identity matrix. Like that. What is a to the power of 3 going to be? Well, we just did that here. We're going to end up with the original matrix, right? And then if we take this matrix, multiply it again by the original, so a to the power 4, that's going to give us again the identity matrix. And so hopefully you can see the pattern that for every even exponent, we end up with the identity matrix, and then for any odd exponent, so like a to the 5, if we follow this pattern, we know it's going to be -1, 3, 0, 1, right? It's going to be the original matrix. For any odd exponent, it's always the original matrix. Well, because 44 is an even exponent, right, we know that what we're going to end up with is the identity matrix 1, 0, 0, 1, like that. Right, so with these kinds of questions, what you want to do is do a few iterations of the pattern initially, try to see what the pattern is, and then from there you could extrapolate to whatever exponent they are asking for. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.